communication through local area networks, or it could be capable of wide area networks. Okay, so ibig sabihin,
Hello, hello, hello.
once your server is
Sorry,
connected
sorry.
to a
Ano, saan
network,
yung
it's
ano?
basically a distributed
Key?
type of operating systems. So it is basically managed by a network operating systems or NOS. But commonly, nung nag-evolve yung operating system and computer systems natin, ito na yung tinatawag natin ngayon, which is the PC. Yung PC is a personal computer coined by the IBM yan. So, si IBM ang nag-coin yan. So, yan na yung term na ginagamit natin. Or, sometimes we use the desktop system. Kaya kung mapapansin mo, dun sa activity na pinagawa ko sa inyo na mag-install kayo ng VirtualBox and the operating system. The operating system nyo is a desktop type. Okay. So, pag sinabing ganito, this system is basically a type of the system we're in. It's either you use it as a multi-user.
Mamaya pa tayo, di ba?
Sa isang PC.
Hindi, di ba sabi niyo sa 11 daw tayo start?
And you'll be able to multitask the activities within your system.
Ano,
So,
start?
yung PC and desktop is basically runs on different versions or different platforms. So, meron tayong Windows yan. So, kung mapapansin mo, may Windows platform for Windows 10, Windows 11, okay? And, siyempre, the Mac OS. So, meron siyang sariling desktop type. So, inside of this is basically a DOS or PC-DOS or personal computer disk operating systems. Okay? So, ayan yung common na ginagamit nating terminology, which is PC. Okay? Now, another, in terms of evolutions, is basically the RTOS. Okay? So, pag sinabing RTOS, it's basically a real-time operating system. That's RTOS means. So, it's another type that you'll be able to multitask. So, you can do multitasking here. Aside from that, ginagamit siya for feeding real-time operating systems. Okay? So, what does it mean? Okay? So, ginagamit itong mga to sa real-time computing. Kaya nga, real-time operating system. So, real-time computing, such as some common applications is, let's say you are using this one for robotics. You use this one for embedded systems. Katulad ng, let's say you're doing a project in RPi. Okay? So, you'll be able to use the microcomputer, which is the RPi, and install an operating system on it. And then, you try to drive an actuators, a motors, a timer, and so on. Okay? So, these are all. You can use this one in yung mga RTOS found in the ECU. So, kung may sasakyan kayo, may electronic computer yan sa loob. So, it's basically running on the real-time operating systems. Okay? Sa planta, gumagamit din ng mga RTOS katulad sa industrial automations. So, industrial automation. So, sa planta, normally, very limited na yung mga tao, mga operator sa loob niyan. Okay? So, mostly it is run by and powered by a robots. Okay? So, it could be an industrial robots and so. Okay? So, in RTOS, usually used in spacecraft. Okay? So, some of the applications here is it could be more on industrial, large-scale computing for servers and so on. Okay? So, most likely, the RTOS now is very demanding. Okay? Because of its functionality. Okay? Now, see, RTOS can be classified into, so meron siyang we call it hard real-time operating system. Okay? And we have the soft, okay, real-time operating system. What is the difference between the two? Pag sinabi nating hard, this is more on an applications for critical tasks. Okay? So, if you are into most complicated assignments na ginagamit natin, let's say for example, it requires you a, a real time uh, uh, collections of data in a storage. So, mas maganda you use the hard real-time operating systems instead of the soft operating system. It's basically uh, uh, the real time is more on focus rather than critical tasks. Okay. So, yun yung pinagkaiba niya ng hard. So, due to less restriction, etong soft ginagamit natin. Some examples nito ay industrial robots. Okay? So, more on robotics ang software real-time operating systems. Okay?
Yeah.
Now, let's talk about the services. Okay, so this is another chapter dun sa PowerPoint niya. Okay, let's talk about services. Okay, ano bang ino-offer ni operating system when it comes to services? So, most common, there are 5, 6, 4, depende sa book na ginagamit natin. So, the operating systems offers program executions. Okay? So, what does it mean? Okay? So, di ba dun sa unang lectures natin, so we have a piece of program actually running on your systems. So, the purpose of the computer system is basically allows you to execute programs. Okay? So, yun. Kaya may OS ka sa loob kasi para makapag-run ka ng application, makapag-run ka ng isang systems, if it is a developed systems, so the operatings will have a convenient way of running it on the background. Okay? So, once na mag-run na to, so si program will be able to run through an OS, you'll be able to allocate properly and deallocate memory. So, because of execution, so pwede kang mag-allocate ng memory, pwede kang mag-deallocate ng memory, and
Okay na yun, par.
you can use CPU scheduling. Okay?
Wala pa naman tayo naturo ulit, no?
Now, another services that the OS offers is basically the I/O operations. So, as we all know,
Ano to,
sa
save
isang
ko?
hardware natin, sa isang computer systems natin, marami siyang na-connect na devices. So, each programs, yung hardware mo, basically may program yan, may software yan.
Yung ano na lang,
Lagi
tawag
nyo
dito,
tatandaan to.
Linux.
Kaya sa development, napakalawak na computer engineering.
Ang
Kasi,
yan. Kung sabi ko dalawa, naka-strip ka pa.
may mga kakilala ako na ang trabaho nila ay
May
device
pinapaturo
driver
lang ya.
developer. Ay, doon ako narinig mo na to.
Ah,
Okay. Ano ba itong mga device driver developer? I'll give you a hint para just in case na gusto niyo maging trabaho to.
anong code na itong
Let's say for example,
tawag dito?
bagong OS.
So, kailangan mo talaga mag-pass to dyan. Ano sa
Si
wanap
hardware
ka, ano
company,
eh.
magde-develop yan.
Kala mo si Eko ni Benton eh. Nag-i-echo si sir eh.
Joystick. Hindi.
Sa Mike Mikael, parang tanga.
Manibela. Okay.
Tanga, magka-touch to kami.
It's basically a steering wheel.
Alala ako, pempre asaran.
So, yung steering wheel, gagana siya sa Windows 12. Okay. So, si device driver, so because of the services ni OS, dapat gumawa siya ng driver na magaran yung steering wheel sa loob ng Windows 12 o Windows 13 or so on, na hindi pa nilalabas yung OS. So, ibig sabihin nun, guys, ngayon, yung mga developers natin, they are producing now a program that will run
Yung sa 3.1, yun lang din start.
operating system na
1030.
ilalabas ni Windows o ni Mac. So,
Ah,
ito yung
si
mga
yes.
sila yan. So, dito papasok yung I.O. Okay, ano ibig sabihin nun? Kasi, kapag may bagong Walker, hindi late ka na nga nag-enroll. Late ka pa rin pumasok, Walker. Okay. So, nawala tuloy ako. So, ibig sabihin, in development community, we'll be able to involve the use of the input-output. So, kapag naglabas tayo ng bagong device, which is hardware, it will be able to run onto our operating systems. That is our primary requirement. So, developers are basically onto the I.O. Okay. So, dapat gagana siya. So, pag kinunit mo yung steering wheel, gagana siya sa Windows 12, 13, 14, or and so on. Pag hindi siya gumana, so, you need to tweak it that will be able to run to the newest operating systems. Okay? Another services na in-offer ni OS is basically file system manipulation. Nakita niyo yung lecture natin last meeting, which is the 3. Yan. So, same thing. Si OS, kailangan niya i-output yung program mo. Okay? Para ma-output niya yan, so it will take the use of the storage. Okay? And si operating system ang gagawa niya. Let's say, for example, mag-retrieve ka ng files mo sa hard drive mo. Mag-retrieve ka ng files mo sa networks. Mag-retrieve ka ng files mo sa through FTP. Yan. Through clouds. Okay, which is common na ngayon. Okay? So, kayang-kayang gawin niya ni operating system. So, it could be able to do manipulations. Aside from retrieving, it could be deleting files, and so on and so on. Another is basically communications. Ano naman yung communications? Okay, from the word communications, si process basically needs to communicate with other information which is executing. Okay. So it could be a process wherein it is running on a computer system or running onto the different computers. Ibig sabihin, you are into an IT department, so there is a specific file that you'll be needing in your development module, so pwede mo siyang kunin. Okay, through networks, through file forwarding. Okay, so it could be in terms of shared memory, okay, or it could be a in form of message. So it's either a shared type or a message passing. So these are the instances that you'll be able to use for you to be able to communicate with the use of the operating systems. Okay? Next is basically error detections. Okay? So bakit mahalaga yung error detections? So again, meron tayong major discussions about collision detections. Okay? So bigyan lang natin ng a little background yung error detection. So part ng operating systems natin is most likely nag-error yan. During the time when we're using Windows XP, napakadaming bugs. Pero yung bugs naman na yan ay we could call it, repairable. Okay? But in any case, siguro sa isang araw, nakakatatlo, apat kaming bugs sa Windows XP.
Oh my God.
Mahilig
Nagutom
yung
ako, guys.
memory error, mahilig
Masarap
ang Windows
iluto.
mag-hang. Yung automatic nag-hang yung PC. Okay? So, hindi nyo na nararamdaman ngayon yan eh. Okay?
Ano to, 12 a.m. na madaling araw?
Process dun sa Windows XP.
Yung open ni sir?
Ang daming incompatibility issues si lower
Tama nga.
versions ng operating
12 to
system.
ano nga daw
So,
eh.
bakit mahalaga na meron tayong error detections?
So, mamaya umaga, madaling araw, yung start ng exam. Hanggang,
Lagi na lang tayong,
ibang buhay yan eh.
let's say for example, you have
Pwede na.
sa planta mo running ang
Literally sa buong araw eh. Madaling araw binuksan yung exam eh.
Windows 11 ayaw mag-install yung mga tao. Kasi they are encountering some bugs during the installation. Naghahanap yan ng
Bukas yun, di? Ay, mamaya yun, di ba? Mamaya na.
ng board. Okay? So, aside from that, so, may iwasan dito. Kung may error detection si OS, hindi mo na iisipin na ay, lagi ito mag-error. So, ang gagawin ni OS, although nakaka-detect siya ng errors, i-repair niya yan. Okay? So, may monitoring tayo, but the errors could be detected by the operating systems. And less worry na ngayon si users when it comes to basically seeing yung laging nag-errors. Usong-uso dati pa yung BSOD. If you remember this one, this is the black screen of death or the BSOD, yung automatic na lang nag-block yung screen mo tapos nag-shutdown. Okay? So, maraming ways para ma-detect ni OS ang errors, okay? One is basically resource allocations. Yan. Kasi guys, pagka
Bobo kaya pala wala ako.
execution, tapos natapos siya, tapos
Sa 3-1 ko napasa yung assignment dun sa may ano, multi-sim ba yun? Bobo.
So, kung wala siyang maibigay, nag-error
What's a
yan.
3-1?
Okay. What else?
Ano pa rin ako yung sa BS ko dun eh, 3-1.
Multiple environment. Okay. And you're running in a multiple
Nakapagpasa
environment.
naman ako eh.
if
Hindi mo
you're
siguro
running
babagsak dun.
onto that, so meaning you're running in a multiple jobs at the same time. So sabay-sabay. So hindi naman kaya ni memory mo kasi napakalit ang memory. Dati ang memory nga lang namin 256, 512 ang memory ng RAM namin niya dati. Ngayon meron na kayong 8 gig, 16 gig, 32 gig na ukulangan pa yung processes na running in your OS. Kasi napakadami yung niload. Kahit hindi naman kailangan sa PC yun, nilalagay nyo. Okay, napakadami yung games. Okay? And so on and so forth. So, because of this, kailangan may resource allocation si OS. Okay? Hindi nyo nararamdaman yung nararamdaman namin dati na
Sad boy.
because medyo malaki na yung
Sad boy.
Pasensya na sir.
Kasi
Sad boy si
sino ba
sir.
ang nagmamanage yan? Siyempre si OS pa rin. Kaya hindi kanya sina-shutdown, hindi kanya hinahang, is because
Nabutan
maganda
natin
na
yan eh.
ang kernel ni OS na
Wala lang tayo pera.
Another is the accounting. Okay. Ano naman tong accounting? So, accounting is basically, it keep tracks of the users, kung anong ginagawa niya, what kind of computer resources ang ginagamit niya. Okay? So, simple as, it's a record, parang record lang siya, ng mga ginagawa ni users. Okay? Kung mapapansin nyo, may audit log naman si OS, makikita niya kung anong oras mo inopen yung PC mo, anong oras mong pinatay, anong ginamit ng services like I/O, gumamit ka ng printer, gumamit ka ng speaker, gumamit ka ng mic, and so on and so forth. So may recording siya para just in case, makita natin at any point in time na mag-error siya, alam natin yung ginagawa bago siya mag-error. Okay, another is protections. Si OS, si OS basically accept simultaneously and concurrently executing programs. Okay? So dapat yung isang process is not able to have a problem with another process. Okay? So ano ibig sabihin nun? Kasi si OS mo basically accept different jobs. Jobs 1, jobs 2, and so on. So dapat itong job na to doesn't affect the jobs 2. So kailangan protektahan niya yung task na unassign sa kanya. Okay? And that is basically protections. So it ensure that yung habang ginagamit niya, kunwari si job 2, it requires na gumamit siya ng printer. Okay, hindi po siya pwedeng kunin. Yung job 1, kunin niya yung printer tapos siya magpiprint. Hindi ganun na. Okay? There should be a controlled operations ni OS niyan. Okay? It is really important to, again, for protections, to authenticate the users. So baka naman kunwari, sa distributed networks, baka naman may kumukonect. Okay? Na hindi naman allowed to use the, let's say, internet. Okay? And that is basically protections. Okay? Next, in operating systems, especially in services, we have what we call system call. So ano itong system call? It basically provides the operating system interface between the process and the OS. So itong dalawa na to, it provides an interface to this, and that is basically the system call. So the system call basically allows the user level process to request some services, ito yung diniscuss natin kanina, na running on the operating system. Okay, it could be allowed or not allowed. So example, so let's say for example you have the I/O. So you have a I/O input-output process. So si input-output process mo requires a system call. So sabi niya, kailangan daw mag-read and write. Read and write a particular area. Okay? So, ang gagawa nito is basically the OS. Okay? So, there are different system calls na pwede natin gamitin. Okay? Most common would be, sa process control, pwede tayo mag-end. Okay? Ng process. Sabi ko, system call is a process and OS interface. So, pwede kang mag-end. Pwede kang mag-abort. So, if it is a process, pwede kang mag-load and execute. So, any process, P1, P2, P3, and P to the N, you'll be able to load that into your operating system and execute the process. Ayan na yung mga programs na nilaran nyo. Pag nag-open kayo ng file, so it's basically a process. Kaya na natin i-terminate yan, kaya natin i-load, and kaya rin natin i-execute. Okay? What else? Sa process, pwede tayong mag-create. So aside from ending, you can create a process. You can terminate the process. Okay, what else? Sa system call, pwede ka rin mag-waiting. So, you wait until the process ends. Okay? And, sa system calls, you can able to allocate in the allocate memory. Okay? So, sabi ko, yung isang process na yan, it requires you to have a memory allocations. And after completing and terminating the process, you'll be able to deallocate the memory. Or, you will have a free memory. Okay? So, this is for the system call for the process. What else? Sa file management, kaya niya rin to. Okay. So again, one of the services of our operating system is file management. So dito, pwede kang mag-create. Okay. Kaya nakakapag-create ka ng isang folder, isang file. Kaya mo mag-delete ng file at any time because of the operating system. So you'll be able to delete certain images, folders, and so on. If you're using a DOS command, you'll be able to open a file. Okay? You'll be able to close the file. So it could be done in a GUI base or a command line. Okay? Kaya mo mag-read and write. So ibig sabihin, you open a file. When you open a file, and then nag-edit ka ng minor editing and save it, you'll be able to write a file. So ibig sabihin, it's a new file. So pag nalagay mo siya sa secondary memory mo, which is the hard disk, iba na ang locations niya. Ito ang tatandaan nyo, habang umiikot yung hardware nyo, nandito yung niretrieve mo na file. Pag sinave mo yan, nandito na yan. Hindi siya same na nakalagay dito. Okay? So what else? Another services that OS requires you is basically device management. So, anong kayang gawin ni system call dyan? Okay? So, pwede kang mag-request for a device if it is open. So, kung mapapansin mo, once your device is properly installed in your machine, may makikita ka na ngayong logo or icon ng device na yon. Let's say, for example, it's a fax machine, a printer, a webcam, all the I/O which is connected to your computer systems, meron ka ng capability of using that. So, you'll be able to manage that. So, pwede mo siyang gamitin. Katulad yan, ginagamit ko ngayon is I do have a built-in camera, pero I'm using an A4 Tech na 2 megapixel na camera connected in an interface using a USB. Okay, so it could be a USB 2, USB 3, meron tayong Bluetooth. If another connected in my device is basically a Bluetooth mouse. So a Bluetooth mouse which is, ang interface niya is Bluetooth. Bluetooth by 5.0, 5.3 ata to, 5.2 na Bluetooth. Okay, so mga luma is 3.0, 3.2.
Di maintindihan sulat kasi
So,
nakakatamad.
pwede kang mag-dangle naman using wireless. Okay. So,
Ano ka na salita, di alam yung
you can
sinusulat.
to request the device and release the device. Okay, ito yung mga time na gusto mo na siyang tanggalin. Okay, in your operating system. So, pwede mo siyang i-delete via Bluetooth, or if it is an interface via a wired, so you can remove it. So, automatically, hindi niya na matidetect yan. Okay, so kung mapapansin mo, kung naka-Bluetooth ka, naka-wireless ka, automatic nag-i-scan yan. Okay. You'll be able to read and write, okay, in some form. Or, sabi ko nga, you can logically attach. Logically
Ano recording?
attach
Ano ako, si Erwin yung naririnig ko eh.
device
Wala na.
and
Legit na.
i-attach
Tama.
the device.
Nakaraan si Erwin yung may konting lesson eh.
You can have an information maintenance.
Wala pa ako sa 1/4 na pinapanood ko.
Ano naman
Inex
yung
ko na eh.
information maintenance? Okay, the information maintenance is you could able to get and configure your time. Okay? So, kasi pag hindi siya nakatamang
Tignan mo yun, logically attached. Request device. Device management.
mga common technique na ginagawa nila, if I don't know if
Ano yan?
you encounter
Internet.
during
Oh my God.
let's say for example, may software. So, yung software niya is expired na.
iPad, no? Ganon.
So, what we do is, i-adjust
Wala
mo
eh.
yung time.
Pera-pera iyak eh.
And then gagana ulit yung software. Kunwari
Kita mo pa yung ano, Lasal.
CPU nyo is 1 year.
Ayop na.
Pero ngayon, medyo mahirap na gawin to kasi some of the uh, softwares is basically checking for the real time. Okay? And the internet also is checking for the real time. So, si Windows mo unang hindi maglo-load yan. Okay? So, let's say for example, I'll give you a definite example of this one. So, may luma kang laptop or desktop. Okay? Now, yung lumang mong laptop is way back, ano pa siguro? Mga 1997 pa siguro, ganyan. Gumagana pa. Yung desktop mo, mga year 2000. Now, si OS mo hindi yan maglo-load kapag hindi tama ang time niya. Saan? Ang unang i-check niyan is the BIOS.
Pre, paano yun? Alam mo.
Okay. Alam niyo naman yung BIOS, di ba?
Hindi ko alam yun.
Ito yung maglo-load. Kunwari pa nag-power on kayo, kunwari mag-F1 kayo, F2, F12, depende sa shortcut key nyo. Papasok kayo sa basic input-output system. Nandyan yung, kunwari, magkoconnect kayo ng bagong hard drive. Makikita nyo agad doon kung connected. It's basically a BIOS. Okay. Yes, makikita mo yun sa boot options. Kapag yung keyboard nyo may boot options, may makikita kang, let's say, ang boot options is hard drive. Makikita mo yung model dyan. Optical drive. Ito yung sinasabi ng boot options, optical drive or network. So, bago ka pumasok dito, yan yung boot options. Bago ka pumasok dyan, hindi yan ang BIOS. Boot options yan eh. Papasok ka sa let's say F11 or F2 na BIOS mo. Ito ngayon, ang load nito, maglo-load to, papunta ng OS mo na. Or sa optical drive mo o sa network. So, hindi siya papasok sa BIOS mo. So, check mo kung ano yung configuration ng BIOS mo. Ipipress mo yun. Pag power on mo, ipipress mo. Tapos pagpupunta ka ngayon sa BIOS setting mo. So, yung BIOS setting mo, makikita mo dyan yung time, anong mga naka-installed na hardware sa systems mo, yan, CPU, okay, and other specifications, okay? So, dito, ang kagandahan dito, wala ka pa sa OS mo, okay, malalaman niya na kunwari, sa boot options mo, kung naka-boot options ka, or automatic boot yung hard drive mo, pag on yan, kunwari ang boot option mo ay una is hard drive. Okay, so hahanapin niyo yung hard drive. Magche-check yan eh. Okay? I-check niya yung hardware kung connected sa kanya. Kung hindi, mag-error yan. Okay? So pag check niya ngayon, hahanapin niya ngayon yung tamang oras mo. So hindi ka niya ibuboot kapag lumang-luma na ang device mo. Pag naging tech kayo someday, makaka-encounter kayo ng ganito. Okay, you need to change the time bago yung mag-boot sa operating systems mo. Pagdating mo ngayon sa operating systems, yung applications mo naman, should be correct time. So, tama dapat yung oras. Kapag hindi yan tama, hindi rin ko-connect yan. Okay? That's basically what happens here. Okay? Sa information maintenance. So, dapat naka-maintain yung informations mo. Ibig sabihin, you can get the process file, okay, using the information systems, okay. You can check the device attributes. Ano ibig sabihin nun, guys? Okay. So, let's say, for example, ito yung PC mo. So, nag-connect ka na nag-connect ng hardware dyan. Let's say, bagong webcam. Yung webcam mo, si OS, may tinatawag tayong, aside from the process ID, PID, meron tayong tinatawag na device ID. Okay, I'll give you an example of this one para mas ma-appreciate nyo. So, let's say, for example, bumili ka ng bagong machine. Okay, bagong PC to. Nag-install ka ng OS dito na lagyan natin mga Windows 11. Now, nasira itong Windows 11 mo. Na-corrupt. Okay. Nag-install ka ulit ng Windows 11. Si Microsoft, kaya niya mag-detect ng device ID. Okay, alam niyo ba to? So, ibig sabihin, huwag kang mag-pirated. Kasi license ang OS mo eh. Mag-install ka, i-activate mo yung OS, may internet ka dapat I-check niya yung device hardware mo. Kukunin niya dito yung attributes eh. Device hardware mo. Gamit yung in-install mong Windows 11. Kung license yan I-check niya yan if yun yung ginamit mo nung in-install mo yung this particular license. So, i-activate mo lang siya. No need to install pirated. Nagigets niya to?
Pre, wala lang ako naiintindihan yung pinagsasabi niya.
May kausap ba ako? Nagigets niya to? Itong part na to?
Yes po, sir.
Okay. Sige. Okay. So, and that is basically one of the information maintenance ni operating
Ako din eh.
system. Okay. So, you can do that. Okay. Now, we have what we call communications. Okay. So, in services ni OS, we have the communications. Diba? So, what we can do here is, through a infrastructure such as LAN and WAN, Bluetooth, or any other communication channels na meron kayo, pwede kang mag-send. Pwede kang makareceive ng messages. Okay? So, you can establish communications. Let's say, for example, a remote desktop connection, RDC. Okay? You can check the connected devices remotely. Let's say, for example, ito yung PC mo. Yung PC mo, you have a LAN here connected sa SAN, sa storage area network. So, ibig sabihin, pwede ka mag-retrieve ng file dito. Yung, from here, pwede kang kumuha ng file at gamitin sa PC mo. Okay. So, ganyan yung operations sa communications natin. Okay. Now, and that is basically services that the operating systems offers to us. Okay. Now, last time we talked about kernels, diba? So, let's talk about now OS layers. So, ano ba itong OS layers? Okay. So, there is a specific structures of the OS layers. Okay. Ano makikita natin dyan? Ang una natin makikita is, let's say, you have a block diagram. Okay. Now, an operating system layer is basically, you have a new operations coming up. So, and that would be your layer 1. Okay. So, This is new operations. Now, meron tinatawag tayong hidden operations. So, sa loob ng layer M natin, okay, in the new operations natin, may another layer dyan. So, it's a hidden operations. Okay. Which is a layer M-1. Okay. So, these are the existing layers na meron kay layer M. Okay. So, paano siya? Okay. So, sa loob nito, let's say, for example, you have an operating systems. Okay. So, on top of the operating system is the applications. Ito yung mga Word, Excel, PowerPoint nyo. Like Suite, Microsoft Suite, yung Office Libre, or games for that matter. Okay? Now, sa loob nito, okay, meron tayong API. Di ba sabi ko sa last meeting natin, lahat ng programs may sarili-sariling API yan. Okay? O yung application interface niya. Or application programming interface. Okay? So, each of the applications here ay may application programming interface. Ito yung UI na nakikita nyo. Which is the API. So, yung API nyo has API extension. Any of the three applications na nataas. It could be a games. It could be an office suite. Okay. In this case, you do have subsystems. So, it has a subsystems. This one has a subsystems. Yan. Okay. So, para mara natin itong mga to, itong office mo, itong Microsoft Office Libre mo, yung games na gusto mo, meron siyang tinatawag nating system kernels. Ito yung OS mo. So, on top of that, yung mga yan, running yung system kernel mo. Okay? Now, eto mga to, it requires basically a
Hindi ko na rin alam.
So, dito papasok yung mga device DD natin. Yan.
Pero si Sir, kasi in-explain ng ganyan, kung pinapakita niyo yung actual na nag-drawing
system layer.
picture talaga o kaya yung application mismo.
O structures natin.
At then,
So,
tinitignan mo, puro ano.
the microkernel system structures is basically here, kung mapapansin mo, you have the system kernel. Okay? So, yung system
100
structures natin, it basically
Tapos,
moves as much
pangalawang klase pa lang natin sa kanya. Yung
user space. So,
Okay lang yan.
nakikita natin, it's running on the background since the operating systems.
yung subject na yan, hindi
Okay. So, meaning, the communications between your program takes place between the user modules using message passing papunta sa kernel mo. Okay? So, anong benefits ng ganitong
kernel is
structures?
literal.
Ang
Hindi
benefits
siya
nito
kernel na
is we'll be able to extend our microkernels. Okay? Yung
basta pag sa mga ang mga software na
are open.
hindi mo sila sa kernel.
Ibig sabihin, old yung PC hardware mo, pero pwede ka mag-install. Windows 11 tayo ngayon, di ba? Let's say, for example, pwede ka mag-install ng Windows 12. Okay? You can do that. Okay? Another structures of the operating system nowadays is because of the VM. Ito na yung pinagawa ko sa inyo activity. Which
Virtual
is the
machine.
virtual machines.
Yung ano?
Okay, there's a lot of virtual machines out there.
Ano?
Okay? Bakit siya maganda?
Ay, yung mag-voice recording daw yan eh.
Ni ni OS natin, there is a simple a non-virtual machine. Okay? Parang ganito yung illustration siya. So you have a hardware and you do have the kernel. This is your operating system. And you have the process. So kung mapapansin nyo, this one is non-virtualized. Okay? Kasi, hindi tayo pwedeng mag-load ng different kernels into different VMwares. Okay? So, ano magiging mas magandang operations? Kaya naka-VM tayo. So, let's say, for example, you have 1. Okay? You have 2. And you have 3. So, these are all process na pwede mong i-run into your kernel.
Okay.
So, parang katulad ng pinagawa ko sa inyo.
Tama.
So, in virtualization, in a virtual
Upload
machine,
mo nga yan, pre.
may PC ka,
Upload mo yan, pre, dun
Okay,
sa
nag-install
ano.
ka ng
Kunyari,
VM.
papasahan ng
sa loob ni VM mo,
project.
may OS1, may another OS,
Really?
which is Win. This is Linux.
At least, di ba kapag tinanong ka, sir,
Say,
naturo mo,
literal,
ikaw na rin sumagot sa tanong mo.
Okay.
Ito,
Pero you have
papagalitan
one
tayo dyan.
So, because of the OS virtualization and because of the virtual applications that you installed in your machines, kaya mo na mag-run different OS. Okay, so dito ang mangyayari, you have different VM na ngayon. So, you have VM1.
Parang siya yung may hawak ng OS.
And you have the VM3. So, virtualized na yan. So, ano mangyayari dyan, sir? So, magkakaroon ka ng virtual machine. Sir, paano yung virtual machines na sinasabi sa hardware side? Di ba may hardware dito? Sir, dito sa virtualized ko na OS,
1, 2, and 3.
Windows ka, nag-install ka ng Linux. So, isa lang yung Ethernet port ko dyan. Pwede ka magkaroon ng virtual Ethernet port. Okay? So, ibig sabihin multiple.
Ano ba naman?
Okay?
Sarap sa kanin ni sir.
Hold on.
Tinutundaan sulat.
May kumakawat.
Wala ba siya yung parang yung pen, no? Ewan ko. Wala bigla eh. Dapat, ewan ko ba? Di na lang ano yun ni sir eh. Tinry ko din kasi dati, nagsulat ako sa ano ba yun? Sa PowerPoint. Di ba pwede ka magsulat doon? Gamit yung mouse? Sa mouse. Ano eh. Ang hirap. Ang hirap pag talaga magsulat sa mouse. Di ko alam sinong prof natin yung maganda magsulat sa mouse eh. Kaya ganyan. Brush ako muna si El kanina pagpasok. Ano ba? Alala ko na. Sure.
Loko talaga to si ano.
Okay, balik tayo. So, kung ginawa niyo yung activity natin, aside from the Ethernet, so naka-virtualize din yung hard drive nyo. So, mapapansin nyo, nung nag-install kayo ng OS nyo sa loob ng VM nyo, pwede kayong mag-partition.
Ako, kala ko tawag
So,
ako.
mag-ask
Partition
yung,
pa ba? Ano?
upon installation,
Partition
mag-ask
pala?
ng partition.
Kala ko ako
Ilang
yung tinawag.
ilang MB
Muntik na gumumundo ko doon ah.
gagamitin mo para i-install yung systems. So,
Di sir, maganda naman sulat niyo sir.
operations of a non-virtual and virtual. Okay. So in layman's term, it's basically a layered approach. Ito yung nakita niya, layered approach. Okay. So tinitreat natin yung hardware and operating system natin as they were all hardwares. So lahat to ay hardware. So identical yung operations niya. So you are creating a multiple illusions of a multiple process. So even though you have only one single processors, pero siyempre marami yun, pwede mo siyang hati-hatian into different virtual machines. So the resources of the physical computers could be shared to different virtual machines. And that is basically the virtual machines. So, anong advantages niya? Okay. So, highly virtualized yan. Kapag naka-VM ka, okay, si operating systems, kaya niya mag-delete. Okay. Hindi niya papakailaman yung isang process na naka-virtualize. So, this process will not be affected by this one. So, may protection siya. So, you will not be having no direct sharing of the resources. So, may sarili siya. Kunwari, naka-VM ka dito. Try natin to. Pwede ka maglagay ng sarili mong IP address dyan. Okay. even though you're running on your own IP address. Okay. So that's basically the stuff that benefits you for having a virtual machines operating systems. Okay. Now, see, let's talk about a little bit on the computer systems architectures, okay, or the CSA of the operating system. Okay. This is computer system
Computer system.
architecture.
Ang dami naman, lawak naman yung subject na masyado.
So bakit
Ayan, buong
mahalaga
computer yan niya.
i-tackle natin
Ano?
yung computer system architectures? Okay. Para kayo magkaroon kayo ng idea
Ayop yun.
kung paano gumagana yung OS sa loob ng hardware.
Buong computer yan niya eh.
So na typical
Nakakabobo.
diagram, meron kang CPU.
Literal
yan.
na ano eh. Nagiging dating
So
computer ko
yung
eh, no?
CPU nyo, again, this is your microprocessor, your microcontroller. If you're
Ano.
may sarili siyang microprocessors, may sarili siyang memory. If you're running on a
Ayop,
computer system,
CPU na.
meron siyang yan yung R5, Ryzen 5, Ryzen 3, i5, i9, and so on and so forth. So this is the CPU.
So on so forth.
So
Okay.
yung CPU nyo is basically...
Wala kang makalao kay si Sir.
So yung meron tayong
Okay.
FSB, the front side bus, saka side bus natin, low speed bus. So a little bit on that part, yung mga part na requires to have high speed communications, nasa full speed bus yan. Yan yung mga memory. Okay. Yung mga low speed buses naman, yan yung mga buses na nasa that requires low latency, yung mababagal. Ano ba yung mga babagal natin? Keyboard, mouse, monitor, printer, yung mga yan. Okay, and that's basically a low speed bus. Diyan siya na-connect. Okay? So, architecturally, connected yan sa isang bus. Okay, para siyang highway. May mga sasakyan na dapat dumaan sa mabilis. May mga sasakyan na hindi kayang dumaan sa mabagal. So, ganun din ang communications natin. Okay? So, itong mga to, para makontrol ni CPU yan, may mga controller yan, may mga disk controller yan. Disk controller or DC. Okay, ito naman, si printer mo may printer controller or PC. Okay? So, if you're using another device is depende. Okay. So, sa disk controller mo, kunwari meron kang hard disk 1, hard disk 2. So, para makontrol natin yan, gumagamit tayo ng SCSI o yung Small Computer System Interface, PCIe, okay, and so on.
PCI.
Kung may video card ka, video controllers, gumagamit ka ng AGP, Accelerated Graphics Port, or nowadays, you have the PCIe. Okay. Now, this one is connected through a bus. Okay, and then we have the memory controller. And your memory.
Pero recall dito ba ba yun? Sige to. Poso mo mga ba?
That's
Poso mo
basically
mga.
simple architectures.
Ito ang lesson.
So what happens here? So when you when the
Diyan kasi
IO
masyado.
devices and the CPU execute
Gusto kong
this one,
ano ko eh. Maiirit ka sa sulat eh.
in computer systems operation, it basically execute concurrently. So habang gumagamit ka nito, ang CPU nyo, kahit naka-idle kayo, gumagana yan. So hindi siya nag-stop. Even though hindi nyo siya kiniklik, wala kang process na ginagawa. So, hindi siya nag-idle. Okay. Same thing with other devices. So, you can concurrently execute all of this I/O devices. Same with your CPU. Okay. So, each device's controller is charged to a particular hard drive. Okay. Or a particular devices such as this one. So, kung mayroon kang dalawang hard drive, okay, nowadays, ang architecture so meron kayong SSD, Okay, which is the solid state device, and then you do have a mechanical hard drive, which is your hard disk drive. Okay, so ito may controller to. Ito may controller. This one is a mechanical, this one is electronic type. Okay. So, para hindi magkaroon ng should we call deadlocks to mga to, yung mga lags na sinasabi nyo, nagbabuffer yan mga yan. Okay. So, although simultaneously sila, so naka-buff pa rin siya. Kasi yung buffer natin is the controller para hindi siya magsabay-sabay at luminya siya depending on the algorithms na gagamitin mo. Okay? Now, eto mga to, in a simple operations like this, meron tinatawag tayong interrupts. So, when you check your operating systems, may makita lahat ng devices mo. Ay may interrupts. Okay? So, yung interrupt basically transfer the interrupt services routine. Okay? Through what we call interrupt vector. Okay. So, ano to interrupt vector? It basically contains address. Oh, ito yung magsasabi na, oy, nari, IRQ interrupt request. May interrupt request ka ng IRQ8. So, yan may meaning yan. So, you're going to look for the interrupt services running and kung ano yung ginagamit niya. Okay? So, ang nangyari dito, during the process of the interrupts, okay, dapat ma-save siya, yung interrupt instructions, and the incoming interrupt should be disabled para maiwasan natin yung lost interrupt. Okay? So, paano natin maiwasan yung gagamit tayo ng tinatawag nating trap. Okay? Trap is basically a software. Para saan? For interrupt. Okay. So, either yung trap is an error or a request from a user. It's either both. That's interrupt. Okay? And just because the operating system is a interrupt-driven type of softwares. Okay? So, during the execution ng ganito, the CPU basically reserve or preserve the state of the CPU by storing a registers and program counter. Sa loob ni CPU mo, so nagkakaroon tayo ng interrupt handling. So, paano niya i-handle yung interrupt in the CPU environment? What does it do is, basically, sa loob ni CPU mo, meron dyan tinatawag na registers. So, normally, it's a 32-bit registers. So, as we go along, i-discuss natin yan. Okay? Now, inside of this one, sa fetch and execute cycle, meron dyan tinatawag na PC, or what we call program counter. So, itong dalawang to, so the operating system basically store it, yung state na to, into the register. So, sa loob nito kasing 32-bit register, meron dyan temporary registers. Okay, when you do programming in low-level programming, pwede mong gamitin yan as what we call temporary registers. So what does it do in interrupt handling is it determine what type of interrupt ang na-receive niya. So kanina, sabi ko, it could be a vector type or it could be a pooling type. So common example is for printers. Okay? So, during the executions, Okay? So normally, so you have the CPU and you have the I/O. Okay? So ano bang ginagawa? So there are different activities and services na ginagawa niya. So let's say for example, si user nag-load ng isang process. Okay? So this process now is basically executing. Okay? Lagyan natin ng timing diagram. Okay? So nag-load ngayon si yan. Nag-load siya. So the process now is executing. Any process for that matter. Okay? Magda-drop yan. Okay. Why? So, dito sa operations natin, may mga pwede tayong gawin. Okay? Let's say, yung I/O natin could have an I/O interrupt. Or, the I/O is idle, so wala siyang ginagawa. Tulad ng printer, hindi ka nagpiprint. And, transferring. Okay? So, you request for an I/O. So, the CPU user execute the process and request for an I/O. Okay? So, once the transfer is done, this one, request to, and the process or the transfer is done, okay? So, pagtapos nun, mag-idle ulit siya, mag-request ulit ng another I/O. Okay? And then, dito sa users natin, okay, at what point matatapos yung executing? Kapag yung operations natin ay tapos na. Okay? So what happens here? So when the I/O starts, nagkakaroon tayo ng control to the user program only upon the completions. So pag natapos yung process na ginagawa ng ni-request nating I/O, okay, that's the time magte-terminate siya. Okay? Or, anong gagawin niya? Maghihintay siya. Anong hihintayin niya? Yung I/O matapos yung nakalagay sa kanya. So, until the next interrupt, si CPU mag-idle. Maglulup siya ng maglulup until magkaroon siya ng access to the memory. Okay? So, until the such time, si users has no control over the I/O completions because si OS na nagagawa niya. So, ano mga gagawin niya? Mag-system call siya, check niya yung device if it is connected or not. So, may table yung I/O natin which includes the type, the address, and the state. Including the memory, meron din dapat address yan. And the I/O index value. Okay? So, paano yun? So, sa isang operations na nangyayari, so you have the user. So, si user requests a process. Okay? Now, yung process na yan, so dapat meron niyang device driver, may interrupt handler, may hardware transfer. Para ma-execute niya. And that is basically on the process of synchronous. Okay. Sa asynchronous, meron siyang, this is a complete loop. Okay. This one is ang process nito sa asynchronous is basically maglo-loop siya dito sa part na to, which is upon request of the process, wala siyang waiting, dire-diretso lang siya. No waiting at all. Hihintayin niya lang matapos yun, diretso. Okay? Now, sa process na to, it requires us to have an hardware. Pero, sa structures na to, wala tayong memory. Okay? So, let's talk about the DMA structure. Or direct memory access structure. So, dun sa unang discussion natin sa OS, ito yung CPU nyo. Ito yung memory nyo. O RAM. So, ibig sabihin, talagang may direct access siya. Bakit? Kasi, ang mga I.O. natin requires to have a faster access to our memory. Okay? So, may mga high-speed type tayo, katulad ng mga video cards yun na ngayon. So, dapat, kung mapapansin nyo, very bulky eh. Tignan yung structure niya. So, may CPU ka dito. Tapos, may memory ka. Yung memory mo requires a lot. Dahil, nag-games ka. Kahit sabihin mo naka-16 to. Yung memory na to, ang properties nito guys is basically shared. Hindi lang yung games ang gumagamit yan. Lahat ng operations na ginagawa mo, lahat ng process na ina-assign mo sa operating systems mo, gagamitin niya yung memory. Okay. So, ano nangyari? Nagkakaroon ng traffic. Nagkakaroon ng congestion. So, what happens here? Sa new architectures natin, may CPU tayo, may memory, may GPU tayo. Kung mapapansin mo yung GPU nyo, may RAM na yan. So, every time na mag-load ka ng games mo, ang gagamitin niya is yung RAM na to. Sir, pwede niyo ba gamitin to? Yes, pwede din. Shared yun eh. Okay? So, may algorithm siya na pwede niyang gamitin yan. Okay? So, yung structures kasi natin ng direct memory access, para siya nagkakaroon it's basically device controllers that transfer the blocks of data from the buffer storage directly to the memory without CPU interventions. So, walang pinalaman si CPU. Okay? So, what happens here? Okay? So, yung memory structures natin, may main memory tayo. Meron tayong secondary storage. Okay? May other memories tayo like magnetic disk. Okay. Etong main memory natin is basically a large storage. Okay? So, sa main memory, si RAM mo, may access kay CPU. Sir, may memory ba si CPU? Architecturally speaking, may memory to si CPU? Hindi nga. Tawag na tayo ng kahit isa lang. Ano may dynamic?
Tawa kayo, magtatawag. Wag.
Baleta.
Balita! Munti ka na, Mario! Ay, ay, ay!
Sir, ako po yun, sir.
Yes, oo.
Yes po. Meron po memory dun sa ano.
CPU. Anong tawag doon sa memory sa CPU?
ROM!
Ano po, sir? Wait lang po. Disk po, sir. If I'm not mistaken.
Wrong? Sige, tawag.
Rom. Rom, di ba? Hindi ang RAM sa ano eh.
Sabi ni Ambal, cache memory. Okay, sige. So, paano naging memory yung cache memory, Ambal? Can you explain briefly lang without typing and searching sa internet? Sige. Ambal? Wala kang mic. Okay, sige.
Ano tinatanong mo, sir? Yung cache memory? Kung ano daw yung cache memory? Ito daw, sa ano daw, cache memory is faster but has a smaller capacity than RAM. Pero mas mahal siya.
Ano lang, break tayo 5 minutes.
Break na din! Pero, 5 minutes break. Diyan, lumurumon din ng mga tao eh. Lumurumon din ano. Get that 30, bro. Skip mo muna. Ano? On the box? On the box? Tapos sa gilid ng box? Paano naging on the box? Bobo. Big... Ano?
Tapos siguro, kanya, maraming si Benedict lang, sabi ni Benedict, ay, nagsawa ko sa kasi kung sinabi ni Benedict na hiniramin lang, ay, kung mag-aano yung kasi nagdadami.
Anong tanong niya, sir? Pagtriman ko kaya to. Ano ba daw nauna? Ano ba daw nauna? Itlog o manok? Ah. Ano ba daw nauna? Itlog o manok?
Kasi, hindi ko tayo. Ay, si Tansi, ano lang yung matatabi nito? Sino ba yun? Or nag-aabi na?
Oops.
Ano?
Hindi kasi
Oo, yung tapos, yung kumain kami siya, di ba? Tapos, ang sinunod na, yun lang. Dahil ko siya
Ay, napag tumitugtog ba na yung mga jingle nila ito?
pero gusto na makakita. Kaya yung ano din, yung makikita ano na yun, yung mag-ano yun, mga sabi. Kasi, ano ba talaga pakiram? Ikaw, yung sarili. Pero sila benefit, yung pinaka-ano yun. Siyempre, pinaka-ilang ka, para masabi mo pa rin. Eh, kung, di ba siyempre, kung sinabi ni Becky, hindi ka lang yung pera. Ay,
Oo.
hindi naman pala sabi.
Tahimik pala.
Hindi sa kasi, bakit ang anak sa kanya? Dahil kung si daddy mo, may kanya, humingi si daddy mo ng pangulong ng medical. Kung nag-aaral sa medical, magkasabay sila magtanong. Tapos nandun practically sila. Pero siya yung taga-ano ko. Hindi na siya nakapili. Ganun po pa rin. Lagi na lang. Kasi nandun yan. Kasi wala naman tayo magkakapat sa kanila. Sumunod niya.
Very nice. Ako, Will.
Ayop to si Al.
Tapos na ito na. Ay, yung ano to, ay to, medyo gago talaga eh, no? Kasi nakainom na sa coffee ko.
Samantala, hindi naman,
Okay. Balik tayo. Ano ba yung tanong ko? Sabi ko, if
Sabi mo na kung ano
yung
na una.
memory, so may sumuot kanina, it's basically a cache memory. So, precisely yung CPU yung meron siyang cache memory. So, cache, it's basically cache ang basa sa kanya. So, meron tayong level 1, tsaka level 2, cache
Ano
memory. Okay. Aside from that, ano pa?
Kasi, nakakash talaga, hindi siya caching. Ba?
Kake yan.
Sino sabi? Tanga.
Virtual memory.
Parang, niya random breakdown niya lang kung ano,
Okay.
di talaga yun yung actual na pagbasa ng
Yes. Okay, sa hierarchy, di-discuss natin yan. Pero, sa loob ng CPU, meron siyang registers. Register is a temporary memory, which is the faster memory. Fastest memory. Mas mabilis pa yan kay RAM. Si RAM kasi is basically a DRAM. It's basically a dynamic random access memory. It means it refreshes millions instructions per second. Ang type ng register is basically an SRAM or static random access memory. So, bakit hindi na lang ginawa ng computer engineer na ilagay dito? So, hindi siya pwede. As we go along. Sa architecture nyo, di-discuss din yun. So, ito ang pinakamabilis na memory sa lahat ng memory. Hindi ito. Ha? Okay. As we go along. Now, kung mapapansin nyo, so you have the main memory which is the RAM. Okay? Which is the large memory na meron kayo. Ngayon, yung memory nyo nasa 32 gig na. Okay? So, yung extension ng memory natin is basically a main memory which is provides you with non-volatile type. Okay? Which is the second storage could be your hard disk drive. Ito yung sinasabi niya kaninang virtual memory. And other type, yung mga magnetic type of disk na mayroong disk controllers. Okay. Now, let's discuss a little bit on the storage. Okay. So, bago natin balikan yung discussions natin ng memory. So, you have the storage. Okay. Sa storage natin, pwede natin siyang hierarchy of storage. We call it hierarchy. Hierarchy of storage. So, yung hierarchy of storage natin, pwede natin siyang i-organize into different should we call this para siyang attributes niya. One is speed. Gaano ba kabilis yung storage? Mahal ba siya? And its volatility. So sabi ko kanina, sir, ba't hindi na lang ilagay dun sa RAM para mas diretso na siya? Yung accessibility niya mas mabilis. Okay. Now, papasok dito yung storage device hierarchy natin. Okay. But before we proceed with the storage hierarchy, one of the benefits kung bakit tayong hiwala yung RAM dun sa memory is because the idea here is what we call caching. Ano to bang caching? Caching is basically copying information.
Hindi nang huli na si
into faster storage. So,
Okay,
ibig
sabi ka dyan,
sabihin,
pagdaling yung motor
may
nyo.
gagamitin
Ito daw
kang,
tapos. Ako din ang huli na senior. Okay lang yan.
ilagay mo muna yan sa pinakamabilis na memory. I-cache mo muna siya. Okay, yan yung mga nararamdaman nyo ngayon. Di ba? Kapag nag-open ka ng file, kunwari Word, medyo it takes 3 seconds. Nung in-open mo another Word, naging 2 seconds. Nag-open ka ulit, naging 1 seconds. Kasi yung Word na executable file, naka-cache na siya. Okay? Sa caching natin, ang last memory na ika-cache niya is basically nasa main memory. Okay? Papuntang cache memory. So, paano yun? Okay? Sa hierarchy of memory, meron tayong, ano yung sabi kong pinakamabilis? You have the registers. Followed by cache.
So, wala.
Okay?
Diba?
Followed by main memory. Followed by electronic disk. So it could be SSD. Followed by magnetic disk. Ito yung mga tape drives. Followed by optical. Ito yung mga CD, DVD. Okay? And so on. Okay? So, pwede din magnetic tapes. So, anong sabi ko kanina? Because of the caching, informations para mag-run yung isang process, kinokopya natin sa faster storage. Kung mapapansin nyo, ito ay nasa loob ng CPU. Ito ay magkakaiba ng hardware. So, pag open natin ito, nag-load tayo ng, nasa electronic disk tayo, nasa hard drive. Pag open natin ng executable file, ilo-load natin yung kay memory. Okay? Until we reaches and copied it to the faster memory. So, etong main memory, ito yung last cache for the secondary storage. So, we use the high-speed memory to hold recently accessed. So, na-cache na siya. So, every time na mag-open tayo ng file, na-cache na siya. Now, sir, mapupuno ba itong cache mo? Kailangan mo ng management yan. Sa OS ulit yan. Okay? So, it requires you to have a consistent and simultaneously stored information in one level. Okay? Para maging consistent yung operations. Kaya, nararamdaman nyo to. Pag na-cache na isang applications, the usual na speed niya mas mabilis na compare mo the first time you open the file. Okay? Now, and that is the thing with the caching. Okay? Now, paano naman mapoprotektahan ni hardware? Okay? So, there's a lot of hardware protections na pwede natin gawin. Okay? So, the first one is what we call dual mode. Okay? The other one is the I/O protection. Okay? And memory protections. So, dapat may mga protections yan. Okay? So, in this case, okay, memory. Hardware, I/O, hardware protection. Siyempre, hindi mawawala ang CPU natin. Okay. Now, eto mga to, it requires us to have a protection for each mode of operation, especially sa hardware. Pag nag-access tayo ng mga hardwares natin, dapat protected siya. Okay? So, let's say, for example, sa dual mode. Okay? So, kung mapapansin mo ngayon, meron siyang protections over the users, katulad ng admin rights, di ba? Hindi ka pwedeng mag-run, mag-install kapag naka-user ka lang. So, it's basically sharing system resources. Okay? Monitor mode. Okay? Or system mode. Okay? And so on. Okay? So, dito sa dual mode, pwede kang mag-user mode. Pwede kang mag-monitor mode or both. Ano ginagawa sa monitor mode? Sa monitor mode, yan yung execution in behalf of the operating systems. Okay? Protection. Paano naman yung protections? Okay? So, all of the input-output instructions natin are basically privileged instructions. So, dapat, si user program should have never gain control of the computer in a monitor mode. So, ibig sabihin, yung user program, as part of execution, should store a new address into the interrupt vectors. Okay? So, lahat ng I.O. natin I.O. instructions are privileged, basically. Pag sinabi namin memory protection, okay? So, dapat protected ang memory natin, especially the interrupt vector, yung katulad discuss natin kanina, interrupt vectors and interrupt service routine or ISR. Okay? So, dapat alam niya yung pinaglalagyan niyang memory. Ibig sabihin, sa isang registers kasi, na 32-bit yan, may mga part lang dyan na pwede mong pag-storan. So, lahat hindi pwede yung 32-bit. As we go along, i-discuss natin yan. Okay. So, we have the base registers and we have the limit registers. So, yung base registers natin, yan yung nag-hold ng smallest in legal physical memory. Kunwari, nagpo-program na kayo sa low-level programming. May specific registers lang tayo na pwedeng lagyan. Okay? And you should know the limit of the registers. Ibig sabihin yung size ng range nung memory na i-access mo. Okay? So, protected yan. Kaya kung mapapansin nyo, may mga memory, may mga storage, kapag in-install mo yung OS mo, nandiyan na yan. Okay? So, hindi mo na siya pwedeng baguhin. Okay? And we have what we call hardware protections. So, pwede mong, you can execute it in a monitor, which is unrestricted. Pero sometimes, ito ay protected also with the memory protection, which is you should know the base registers and the limit registers para magkaroon kayo ng protections when it comes to memory, and which is the hardware. Si CPU are very much protected. Okay? Bakit? Okay? Most common, ang nagiging problema natin dito is the timer. Okay? So, the timer basically decremented every tick ng clock cycle natin. Ito yung nakikita nyo nga, 3.5 megahertz. Ito yung clock speed niya. So, the clock speed basically decrement every tick. So, kailangan nating ma-maintain yung timer natin, which is the interrupts computers para ma-ensure natin that hindi maubos yung frequency mo. Okay. So when the timer basically reaches the value 0, pag value 0 yan, meron tayong interrupt. Okay. So, and that is basically hardware protections. Now, let's move on. This is another topic, process. Okay. Check your PowerPoint presentation for process lecture. Okay. So, what is a process? Okay. Let's have a concept of a process. So, process, as I mentioned before, is a program. A program in execution, or basically a program in running conditions. Okay? Now, yung process natin could be have more than 1, 2, 3, 4. Okay? So, it includes basically the current activity, which is basically represents dun sa context na gumagamit tayo ng, let's say, processor registers. Okay? So, the operating system executes different variety of programs. Okay? It could be a batch processing. It could be a time shared systems katulad ng user programs or tasks like yung process in execution. Okay? So, in process execution, basically, ang nag-run dyan is the program counter, the stack, and so on. Okay? Now, the process is basically execute. Okay? It basically changes the state. Okay? So, we call it process state. Okay? So, as a process executes, it changes the state. Okay? A state we're in, there is accepting new state. Okay? Ano yung new state? Nag-create ka ng process. So, once you create process, you will now have a running state. Okay? Ano naman yung running state? As simple as a process is running. Pero may mga requirements to para mag-run siya. Dapat may CPU time siya. Okay? Nakuha? So, ibig sabihin, i-accommodate siya ni CPU. Okay? Another is what we call waiting state. So, hindi siya ma-process kasi wala pang tapos na process. Ibig sabihin, iba-block siya. Not block na hindi na siya ira-run. Ang gagawin sa kanya, paghihintayin siya. So, if the process is said to be blocked, pag naka-block ang process mo, naka-waiting ka. Naka-waiting ka kasi walang 1. Available I.O. So, ibig sabihin, ginagamit yung printer, ginagamit yung mic, ginagamit yung mouse, ginagamit yung webcam. Okay? So, ibablock ka muna niya. Oy, sabi niya sa'yo, maghintay ka muna. After a while, you have now what we call ready state. Ano naman nangyayari sa ready state? Okay? This is a process to be ready if it needs a CPU to execute. So, dito may CPU time ka, yan yung new state mo. So, blinak ka ngayon. So, kailangan mo ng CPU to execute. So, you are now into the ready state. Okay? Sir, pwede bang ma-stop yan kahit nasa ready state ka na? Yes. Depende sa algorithm. Okay? Na ginagamit. Okay? Now, after nyan, may tinatawag na yung terminated state. Sa ibang libro is end state na to. Terminated state. So, ano to? Finish execution na to. So, ibig sabihin, tapos niya nang gamitin yung I.O. niya, i-release niya na sa CPU. Okay? So, finish execution to. Okay. Nakuha? Now, kung mapapansin nyo, anong pinagkaiba ngayon ng process tsaka program? Okay? What is the difference between a process and a program? Okay? Let's create a state diagram. Okay? So, this is a simple diagram stating the process. Okay? Before we differentiate a program and a process. Okay. So, may new ka dito. So, you have a new. Drawing muna natin ha. So, you have the ready state. Okay. So, you have the running. And this one, I guess, is the terminated. So, end. Pero sa loob nito, may nangyayari. Okay. So, this one is an interrupt. So, pag nagkaroon ng interrupt-driven, so the new state or a process is basically admitted as a ready state. Okay. Now, during the operations, may nangyayari tayong operations wherein nagkakaroon tayo ng waiting. So, from here, may waiting tayo. Papunta kay ready. Okay. So, paano nangyari to? Okay. So, in an operations like this one, the process are basically requested for an execution. Any type. Okay. Now, ilalagay natin yan sa ready state. Okay. Tingnan ko muna kung may available ba na CPU time. Okay. So, i-admit natin siya as ready state. Now, kung may CPU time available, i-run natin siya. Pag nirun natin siya, finish yung execution. Now, what happened here? During the execution, may nag-interrupt. It could be hardware, it could be I.O., depende. So, may interrupt. So, pag nagkaroon tayo ng interrupt, ibabalik niya yan sa ready state. Okay? And then, what happens here? Dito sa running mo, may mga events na pwedeng mag-wait sa'yo kasi puno pa. Hindi pa siya executed. So, ano yung mga yon? I.O. or events. So, pag hindi pa, i-waiting ka niya or i-block ka niya, okay? Kapag yung I.O. mo na ni-request, kunwari printer, nag-request ka ng printer para mag-print ka, tapos na, ibabalik ka ngayon niya sa ready state kasi yung event which requires for the I.O. completions ay tapos na. So, yung event or yung completion ay tapos, i-ready state ka niya and then, i-run ka niya. So, dito papasok yung diferensya ng process at program. So, what is a process and what is a program? Okay. So, both of the process and the program are not executing. It's basically a program. Okay? If it is not executing, it's a program. Okay? Ulitin ko ha. Ang program is not executing. So once the program is executing, it becomes a process. Kaya kung makapansin nyo, makikita nyo sa Control-Alt-Delete nyo, process na siya. Okay? Another, what else? Ang process, malaman natin, ang program is basically residing in on. So yung program natin, nasa nakalocate ito. Di ba nag-i-install ka ng applications mo? Nasa secondary drive yan. Nasa hard drive na yan. Ang process nasa loob ng memory or RAM. Okay. So the process is basically active, which is executing in the background. And this one is basically passive type. Okay. So, sa programming naman, pag sinabi natin program, algorithm yan. Using different programming languages. Okay. Ang process naman, yan yung machine language. Or, yung subject nyo, I don't know kung subject nyo ngayon to, assembly language. Programming. And that is basically a process. Okay? Now, sa loob ni process, may tinatawag tayong PCB. Or what we call process control box. So sa process control box, it's basically information associated with each process. So, let's say for example, ito yung ating PCB. Sa loob ng PCB natin, may process number. Okay? May PC, we call it program counter. Okay? May registers. Okay? May memory. Dapat may laman yan. And then, ito yung files mo. Okay? So, this is basically a process control box. Okay? So, isa-isahin natin. So, in the process states, okay, the state may be new. So, pwede siyang bagong open na program. Okay? A process could be a ready state, a running, or it could be waiting. Okay? So, at this point, yung state na to could hold a what we call a CPU registers. Okay? So, sa CPU registers, I said it's basically a memory. So, sa loob niyan, marami siyang laman. So, it could be an accumulator, it could be registers to. Accumulator, marami to. Base register, etc. Okay? Nakuha? So, how do we schedule the process? Okay. So, running na. Okay. So, how do we schedule the process? So, in scheduling the process, so pwede natin siyang i-queue. Okay. So, the first one is, let's say you're accepting a new state of a process. So, what we do is we accept a queue, a job queue. Okay. So, this job queue is consists of all process. Lahat ng process na pwede mong i-run as a new process. And then, may tinatawag tayong ready queue. So, from the word ready queue, okay, so yung lahat ng process natin sa job queue natin are then will reside to our RAM, which is our primary memory. Okay? And it is ready. Sabi ko nga, ready to execute by the CPU. Okay? So, sa data structure, para siyang linked list. Naka-list lahat. Naka-ready queue header. So, may pointer siya, may first and final PCB. Okay? And the next PCB kung saan siya pupunta. Kaya siya naka-ready queue. So, yung structure niya is a linked list structure similar to what you discussed in data structures and algorithms. Okay? Next is what we call device queue. So, paano naman sa device queue? Yung queue natin basically consists of now all process, which are waiting for an I/O. Okay? So, each device has its own device queue. Okay? So, lahat ng devices na i-require natin, dapat may device queue. Okay? So, paano yun? Natin i-represent to. Okay? So, pwede natin siya i-represent in a drawing. Okay? So, you accept a ready queue. Okay? Na i-accept ni CPU for execution. Pero, mangyayari lang to kapag may available I/O. Kung walang available I/O, i-queue natin sa I/O. So, ang gagawin niya, so the CPU will request for I/O para mag-run siya. Okay? Next. Hatiin yan using a time splice. Okay? And then, dito sa operation na to, meron tayong child executes sa scheduling na to, which is what we call fork and child. This is a fork. And this is a child. Okay. And may control tayo ng interrupts. And let's wait for the interrupts to happen. Okay. So, anong gagawin niya? Okay, during the process of this one. So, marami tayong mga schedulers. Okay, na pwede natin gamitin. Okay. So, what is a scheduler? A scheduler is a decision maker na kaya niya mag-select ng process na gagawin or gagamitin niya or i-queue niya para magkaroon ng allocation kay CPU. And, siyempre, kung mag-allocation kay CPU, i-execute niya yung process na yan. So, sinong gagawa nun? The scheduler. So, si OS, may different types of schedulers. Okay. Okay. The first one is what we call long-term. The other one is short-term. Sa ibang libro, it's a job scheduler, yung long-term. Yung short-term is a CPU scheduler. And the other one is medium-term. So if this is a job, and this is a CPU, what will happen here? So, pag long-term scheduler, isi-select niya muna yung processes from lower hierarchy of memory. So, sa disk, tapos ilo-load niya sa memory. Pag-load niya sa memory, and it's time for execution. Okay? It's basically less frequent. Okay? What about the short-term memory? So, short-term memory, isi-select niya yung memory, yung process, among all the process, and i-execute niyan directly to CPU. Hindi na siya dadaan sa disk, tapos i-load sa memory. So, direkta na siya kay CPU. Kaya short-term siya. So, mas mabilis siya. Okay. Sa medium naman, dalawa ang magiging options mo. Okay? It's either you use the I/O bound, input-output bound process. So, ibig sabihin, you'll be able to spend more time in the I/O rather than the CPU burst. And CPU bound. Ito naman, it basically depends on the computations, but very few of the CPU bursts ang magagamit. Okay? So, what is the context here? Okay? The context here is we'll be able to create a process. Okay? So, to be able to create a process, you'll be able to create that using a parent process which create a children process. Kaya siya nagkaroon ng tree. So, may parent ka and may child ka. Okay? So, every parent create a child. Ayan o, kanina. Ayan. So, si parent basically share resources with each child. Okay? But the parent and child, okay, share no resources. So upon the completion of the execution, the parents, these parents wait for the child to terminate. So dapat yung operations ni child ko or ni children ko ay terminated siya. Okay? Yan yung nangyayari sa Unix operating system. So sa Unix operating systems, gumagamit tayo ng system call. Ang ginagamit natin is what we call fork. Sa Unix to Fork is a system call para mag-create ng new process. Okay? Si exec naman,
Pre, sipag mo ah.
it basically a system call
Nakikinig ka pa rin eh.
para after a port replaces the process.
Paano pa kami? Hindi talaga nakikinig.
Replaces the process. Okay? With a new program. So during the execution, the process executes and decide to exit if it is terminated. Okay? So, ang nangyayari dito is the process could be independent. Okay? And it could be cooperating. So, during the concurrent process natin, executing in the operating system, may either be independent or cooperating. So, pag independent siya, it cannot affect and be affected by other processes when it executing. While in cooperating, pwede siya maapektuhan once the process executing. Okay. So, maraming mga disadvantages and disadvantages ang paggamit ng independent and cooperating. Okay? Now, let's talk about CPU scheduling. Okay. So, ito yung sa last PowerPoint niyo. So, ano ba ang CPU scheduling? Okay. So, the CPU scheduling is a scheduling. Okay. Normally, CPU is very faster. Okay. Kaya ginagamit natin siya para ma-utilize yung operations at yung hardware na meron siya. Okay. So, paano natin siya ma-utilize? So, gagamit tayo ng different approaches. So, pwede siyang CPU2 I/O burst. Pwede siyang CPU distributions. Okay. So, para ma-maximize natin to at hindi masayang yung napakabilis na CPU nyo na i9, anong gagawin natin? Okay? So, kailangan natin i-schedule yung CPU natin.
Grabe namang i9 yan.
Okay. So, paano yun?
i3
Okay.
nga lang.
Si CPU ay may direct access kay RAM. So, anong gagawin ni CPU scheduler? Among the process na nandito, P1 to Pn, isi-select na yan that is ready to execute. Si scheduler ang mag-state ano ng mga process ang ready at ano ang mga process ang mag-allocate ako ng CPU time. Okay? So, paano niya malalaman kung alin doon ang gagamitin niya? Okay, so there's a lot of decision making na gagawin ni CPU. One is, kailangan niya i-switch yung from running to waiting. Kailangan niya i-switch from running to ready. So, basically, running to waiting. Okay. Running to ready. and waiting to ready, and terminates. So, ito yung nagiging operations niya. Okay? So, ano mangyayari? There's a sequence of CPU and IO burst na nangyari. So, magre-request tayo to store and to read a file. So, yan. Store, read, file. Pag nag-request tayo ng store or read a file into our systems, gagamit ka ng I.O., di ba? Kasi mag-store ka eh. May waiting yan for an I.O. Kung ginagamit ba. Okay? After nun, i-load niya yan. Okay? And then, i-wait niya ulit. So, makapansin, paulit-ulit yan. At etong mga to, gumagamit ng CPU burst yan. Ibig sabihin, gumagamit ng time yan, ng CPU. In waiting, in loading, in waiting, in loading, a specific operations for a process. Okay? Now, anong gagawin niya? So, si CPU, meron siyang dispatcher.
Lolo.
Okay? So, kung mapapansin mo, yung rate niya from ready to waiting, okay, ready to ready and waiting to ready, it basically gives the CPU to control. Okay? The CPU process. Okay? So, pwede niya makontrol yan using different technique. Pwede siyang switching context, pwede siyang switching to users, or pwedeng yung kanina, yung short term to long term, and so on. So, in any case, sa operations ng dispatching, may mga time na bumabagal because there needs to stop the operations of one process to start another process. Okay? So dito, papasok yung different criteria and optimizations of CPU. Okay? So, ano na mga criteria natin for scheduling? Okay? Para magamit natin properly, kailangan natin ma-utilize yung CPU natin. Ibig sabihin, maximum potential ng CPU natin. Makes yung CPU natin dapat laging busy. Para magamit nyo. Okay? Another terminology in CPU scheduling is what we call throughput. Okay? Ano naman yung throughput? Number of process, okay, that completes the entire execution. Okay, that's basically a throughput. Turnaround time or TNT, turnaround time. So time naman to. This is basically an amount of time to execute particular process. So ibig sabihin selected lang. Okay? That's the turnaround time. Pag sinabi ng mga response time, this is an amount of times, okay? From when you request was submitted until the first response is produced. So, ibig sabihin, hindi pa sa yung output. Yung time pa lang na mag-respond siya. So, hindi pa siya executed. Okay? So, that's basically it. So, you have the CPU, you have throughput, turnaround time, and response time. Okay? Now, maraming algorithms out there. Okay? So, these are the basic type. So, ang una natin is what we call first come, first serve. Scheduling. From the word first come, first serve. Okay? So, that yung algorithms na to is the process that requests the CPU first is allocated the CPU first. Ibig sabihin, yung unang nag-request, sa yung bibigyan ng unang CPU time. Okay? So, this is basically first in, first out queue. Okay? So, when the process enters the queue, yung PCB natin in the linked list will tail onto the queue. So, when the CPU is free, mag-allocate siya ng head, tail and head, until the process is basically removed. So, uunahin niya yung unang pinasok niya at ilalabas niya yung unang pinasok niya. Okay? And that is basically first in, first out. Okay, let's take a break. 5 minutes break. Thank you. Okay, like that. So, first come, first serve is very easy to implement. So, when the CPU is free, mag-allocate tayo ng process at the head of the queue, dun sa una. Which is, yung running natin will then remove from the queue. Okay. So, very easy siya. Let's take an example. So, considering that we have a set of process which arrive at time 0. Okay. With the length of CPU verse, which is expressed in milliseconds. Okay. Now, let's take an example. So let's say we have process. So we have the P1, P2, and P3. So we have the burst time expressed in milliseconds, which is, let's say, 24 milliseconds. You have 3 milliseconds, and you have 3 milliseconds. Okay? So 24, 3, and 3. Okay? So if the process arrived, at, let's say, P1, P2, and P3. And then, ang ginamit na scheduling is first come, first serve. So what will be the result? Okay? So given that we have a Gantt chart, okay? So ang sabi daw at time 0, let's say, create a Gantt chart. So 24. Eyeball natin, this is 24. Okay? Which is P1. Okay. Next is the P2. So this is 24. 24. Then you have 3. 24 plus 3, that's 27. And 27 plus 3, and that is 30. So what does it mean? So the waiting time is 0 milliseconds for P1. So 24 milliseconds for process, and for process 3. Okay? 30 milliseconds. Thus, yung average waiting time natin is computed at time 0, 0 plus, you have the 24 for P1. So, plus 27. This one. So, you have 0 plus 24 plus 27 over 3. You have 3 processes here. The average waiting time to run the P3 is basically 17 milliseconds. Okay. So if the process arrived in order of, let's say, so this one is P1, P2, P3. Let's say baguhin natin yung order niya. P2, P3, and P1. Okay? So the result would be in a Gantt chart. So the P2 is sabi dito ang waiting ang arrive time natin at 0. So you have 0 to 3, that's your P2. P2 is 3. Your P3 is 3 again. Okay. So 3 plus 3 is basically 6. And your P1 is basically 30. Okay. So, in order of the first come first serve here, ang operations natin ay ang order ng pag-run ng different process natin is P2, P3, and P1. So, what would be the average waiting time for here? So, in here, you start with, dito ay 0 to 3. So, anong average time niya? So, 6 plus, you have 0, or 0 plus 6 plus 3, kahit baliktad to, over 3, yung average waiting time mo is 3 milliseconds. If you run P2, P3, and P1. So, inuna muna yung madali. Tignan nyo dito inuna nyo yung process na napakatagal. Okay? And that is 17 milliseconds. Dito, inuna mo yung konti. Yung 3 tsaka 3. And you have 3 milliseconds. Okay? So, the average waiting time under the first come first serve is generally not minimal. Nagbabali siya depending on the CPU verse. Okay? So, in addition, yung first come first serve is basically dynamic in nature. Okay? Nakawa? Next, another scheduling is what we call shortest job first. Okay? So, different approach yung CPU scheduling. Okay? The scheduling is the shortest job first scheduling algorithms. Okay? Ano yung algorithms na to? Yung each process natin, with the length of the next CPU burst, when the CPU is available, it's assigned to the process that has smallest, kaya nga shortest smallest next CPU burst. So, ibig sabihin yung pinakamaliit na CPU burst. Kapag may the same CPU length sila ng CPU burst, the first come first serve is used to take and break the time. Okay? So, ginagamit natin yung context ng CPU verse mostly for people and textbooks, which is using the SJF type. Okay? So, paano mo siya gagawin? Okay? Let's say, for example, okay? Considering that we have ito, shortest job to. Okay? Considering that you have the following set of process. Okay? So, you have the process P1, P2, and P3. P1, P2, P3, P4. Okay? And you have a CPU burst. Okay? So, P1 has 6 milliseconds. 2 has 8. This one is 7. And this one is 3. So, using shortest job first algorithm, scheduling. Okay. Paano natin gagawin to? So, let's create a Gantt chart first. Okay. So, lahat to will arrive at time 0. So, 0. So, let's say, ang operations natin would be shortest job first. Sa lahat ng to, ang pinaka maigsi na time para mag-run sa CPU ay ano? P4, which is 3. So, this will become our P4. And that is 3 times. Next, na pinakamaigsi na mag-run sa kanya ay 6, which is P1. Okay? So, 3 plus 6, you have 9. Okay? Next, yung pinaka-next niya, 6, 7. So, this would be the P3. Okay? So, 9, it becomes 16. And, yung pinakahuli is 8. So, 16 plus 8, you have, the last is P2. It becomes 24. Okay? So, the waiting time is basically 3 seconds for process 1. Okay? The 16 milliseconds process for 2 and 0 milliseconds for last process natin. So, what would be the average waiting time for this? Okay? So, you need to add, okay, the average waiting time. So, compute for the average waiting time muna nung lahat ng yon. So, the average waiting time would be, you have 3 plus, you have 16 plus 9 plus 0. So, you divide this one to 4, and you have the 7 milliseconds. If you're going to use the first come first served scheduling, pag kinumpute mo to, gamit yung first come first served, ito yon, and you will get, hindi na natin kumputin, you'll get a 10.25 milliseconds. So, 7 versus 10.25 milliseconds versus 7 milliseconds. Mas magandang gamitin si shortest job first. Okay. So, the user will estimate the process time. Okay. Ginagamit si shortest job first sa long-term scheduling. Yung meron tayong short, long, tsaka mid. Ito yung may I.O. Yung short term is basically CPU bound. Ito I.O. bound to. Okay? So, initially, you will have a more lesser average time if you're using the CPU. Shortest job first. Okay? Now, si shortest job first, meron siyang preemptive and non-preemptive algorithm. So, whether you use the non-preemptive and preemptive, it's up to you. Okay? So, depende sa ipoprogram mo. Okay? So, let's say, for example, you have the process for a preemptive and non-preemptive. So, ang pinagkaiba ng dalawang to, there is an approximation length na pwede mong gawin para makita mo yung next CPU burst at ma-predict mo kung anong gagamitin mo, which is the shortest job first or the other way around. Marami pa kasing type yan. Okay? So, ang choice natin dito is the new process may have a shorter next CPU burst if we left the process which is currently processing. So, dire-diretso lang siya. Pag preempt naman, ipi-preempt natin yung current, ibig sabihin, parang i-stop natin yung currently executing process. Hindi siya dire-diretso. Okay? Sa non-preemptive kasi, you will be allowing only the currently running process to finish. So, kung ano yung nakalagay sa kanya, tatapusin yan. Okay? So, preemptive shortest job first scheduling is basically the shortest remaining time first. Shortest remaining time first scheduling. Short remaining time first scheduling is SRTFS. Okay. And this is basically a preemptive type. Scheduling. Okay. Now, for example, you have four process running in your CPU burst. Okay. So you have the process. Okay. You have the P1, P2, and P3, and P4. So yung arrival time natin ngayon, hindi na katulad kanina na time 0. Lagyan na natin ng time siya. Okay? So let's say for example, arrival time niya is 0, 1, 2, 3. Okay? Ang CPU burst niya, okay, to run the process is 8. This one is 4. This one is 9. And this one is 5. Okay. So, gawa natin siya ng Gantt chart. Okay. At time 0, ang unang mag-run sa atin daw ay shortest job to Okay. Ang pinakamaiksi dito is what? Ano? Arrival time natin ay 0. So, yan ang unahin natin. P1. Okay? So, yung P1 natin will be having 1. Okay? Our P2 will have what? So, the P1 is started at time 0. So, it's only the process in the queue. So, the process arrived at time 1. The time remaining for P1 is basically how many? So you have 1, so you have 8, 1 minus 8 minus 1, and that is 7 milliseconds. Okay. So 7 milliseconds is basically larger than the process 2. Yung process 2 natin kasi is 4. So the process 1 will be preempted. Okay? So, i-stop niya kasi mas malaki siya eh. So, the process 2 is scheduled. Kaya siya P2 ngayon. So, P2 is basically, so you have 1, P2 has 1, arrival time is 4, and that is 5. Okay? Next. So, the average waiting time for this, so you need to compute. So, 10, this is what it looks like. So, 10 minus 1 plus 1 minus 1 plus 17 minus 2. Okay. Plus 17 minus 2, that is 5. 5 minus 3. Okay. Divide by how many processes to 4? And that is basically 6.5. So, paano nangyari yun? So, you have P2, that is 10. P2, next is the P4, which is 5. So, 5 plus 5 is basically 10. And that is your P4. Next is, na-preempt natin yon. So, we have the P1. Pwede na natin i-run si P1. So, you have 10 here. So, P1 is basically 8. Okay? So, the P1 now is basically, so this is, kinumpit natin to, this is 7. So, 8 minus 1. So, that would be 10 plus 7, that is 17. Okay? And you have P3, which is 17. Your P3 is basically 9. Okay? And that would become 26. Okay? So, ito yung isa-isahin natin. So, 10 minus 1. 1 minus 1 plus 17 minus 2 plus 5 minus 3 over 4, you get 6.5 milliseconds. Okay. So, pag kinumpute nyo, itry nyo i-compute yung non-preemptive naman. This is preemptive. You try to compute for non-preemptive na hindi mo siya i-stop, dire-diretso mo lang siya, and you will have at least 7.75 milliseconds. So, mas maganda pa rin si shortest remaining time first for scheduling this type. Okay? So, I think it's already 1:30. Okay. So, that would be all for us this afternoon. Maraming salamat sa pag-attend section 1. And I'll see you tomorrow for our elective 1. Okay? So, maraming salamat at
Thank you po, sir.
Thank you, sir.
Thank you po, sir.
Thank you po, sir.
Thank you po.
Thank you po, sir.
Thank you po.